Okay, now that you've learned a little bit about t-distributions and that we use them when we don't know our population standard deviation, sigma, let's take a look at how we would use a t-distribution. So it's going to be very, very similar to what we did with our z as in zebra distributions. And we're going to start with a confidence interval. So we're going to do a 1 mean t interval. And we're still going to use panic, and much of panic is going to stay the same. So we're going to go through this. We'll compare it with our z interval so you can see where the differences are at. So the P in panic is just our parameter statement. That's the 95% confidence interval for whatever mean we're trying to find. Our assumptions are going to be really, really close. So we still have the simple random sample that we need to get our statistical inference. We still have this requirement that we either have a normal population originally or we have a large enough sample, meaning 30 or more. Okay, and that allows us to use the central limit theorem. Now here's where the difference is. So in a t-distribution, the way that you know that you would be doing a t as in tiger interval instead of a z as in zebra is if your population standard deviation sigma is not known. So if sigma isn't known, what you're going to do instead is you're going to get your sample standard deviation. And we represent that with the letter S. Okay, and you can usually get that from your data set. Right, so the name of the test, there's a slight little change here. So instead of it being a 1 mean Z as in zebra, it's going to be a 1 mean T as in tiger. Okay, the I is the actual construction of the interval. And here we have x bar plus or minus z star. Here we have x bar plus or minus t star. So that number for t star is going to be a little bit different. And then we're going to use s instead of sigma. So those two are going to change. And I have that set up in an Excel spreadsheet for you. And then your conclusion is going to be very, very similar. So we are blank % confident that the true mean, again, this piece here is optional, just kind of depending on how the wording works out, is somewhere between blank and blank. So just a couple of little changes, but otherwise this is exactly the same as what we had been doing with the z interval. Okay, so your biggest thing is that we don't know our population standard deviation, so we're going to use our sample standard deviation S. Okay, and that's how we tell which one of these we're using, whether it's a Z as in zebra or a T as in tiger. All right, so let's look at an example of this. We have a landscaping nursery. Jones Nursery specializes in custom designed landscaping for residential areas. The estimated labor cost associated with a particular landscaping proposal is based on the number of plantings of trees, shrubs, and so on to be used for the project. For cost estimating purposes, managers use 2 hours of labor time for planting of a medium-sized tree. So that's kind of the average that they expect. Actual times for a random sample of 10 plantings during the last 10 months follow in times, and I have those times. I've actually calculated the two numbers we need from those. You don't have to worry about that. And we're going to construct a 90% confidence interval for the mean tree planting time. All right, so P for the panic. Go ahead and just put our letters down the side. And we know that we're using panic and not phantoms because it's asking us for a 90% confidence interval. So if it's asking for a confidence interval, that means you're going to use the panic process. So we're looking for a 90% CI for the mean tree planting time. And then our assumptions and conditions, we have simple random sample, normal large, and then no sigma here. So in fact, what you could do is write sigma. And if we know what sigma is, you can write it down. And if not, put a no and then put down what S is. Okay. So in this case, we have a random sample. So that's good. Our sample size is n equals 10, so not large enough, but it is stated that we can assume the original population was normally distributed. So I'm going to circle the word normal, and I'm going to put normal stated. So you want some sort of justification why you chose one of these two. So if it's a sample size, you can just put it down as long as it's bigger than 30, that counts as large enough. But otherwise, some reason why you're choosing which one. And then sigma. So nowhere in here does it tell us our population standard deviation. So sigma is a no. Okay, but I do have S, and so S is equal to 0.52. And that's what tells me that I'm going to do a T as in tiger interval. Okay, so I have a 1 mean T interval. Okay, and let's see, do I have everything I need? I have N equals 10, I have my S, and I have my X bar. So I'm ready to head over to the spreadsheet and get the interval endpoints. All right, so our confidence level here is a 90%, so I'll put 0.9 in. My sample mean X bar was 2.2. S, my sample standard deviation, is 0.52, and our sample size is 10. So that gives me from 1.9 to 2.5 as my interval. So I'm going to go ahead and write that down. Okay, and now I'm ready to go ahead and write my conclusion. So we are 90% confident the true mean tree planting time is between 1.9 and 2.5 hours. Okay, so there's our conclusion statement, and we've gone through panic. And now I just want to go back and look at something. So it says, for cost estimating purposes, managers use 2 hours of labor time as their kind of their average when they're doing a proposal for the bill. And that certainly seems fair, since 2 is within our confidence interval. That is a fair assessment there. All right.